Hello everyone and welcome. In this video we're going to look at the example that we just solved by hand manually. And here's the example where we have two alternative designs, essentially two investment alternatives with different initial investment and annual return over 10 years. And what we want to do is to graphically show the internal rate of return for these two alternatives. Also, since we had to do the incremental rate of return analysis, we looked at the B minus A cash flow, and we want to calculate the rate of return of that analysis as well. As you know, the rate of return is the interest rate where the present worth is equal to 0. So what I'm going to do is to calculate the present worth of these three alternatives at different percentages and graph them so we can see the difference between them on the graph to provide more insights. So let's calculate the present value of alternative A, which requires $300,000 initial investment and annual revenue of $55,000, and we want to calculate the present worth at 1% first. As you know, the Excel function for calculating present worth is PV, and when you open the parentheses you have to pass in the rate. So the rate that we want to calculate this at is 1%, and you have to specify a number of periods, that is 10 years. PMT is the third argument that you have to pass in, and that is the annual revenue. The annual revenue is $55,000 and it's positive. So in order to have a positive value coming out of the PV function, as we discussed before, you have to pass in a negative annual revenue. It's always the opposite sign. So we're passing negative $55,000 here for the PMT. And there is no salvage value, so I'm closing the parentheses here. And that is going to calculate the present value of this uniform cash flow, $55,000 each year. But don't forget that we have an initial investment of $300,000. So what I'm going to do, I'm going to add that here to the present value function. And since I want to copy down the calculations for all these other percentages, I'm going to lock in E3 cells, which is the initial investment, pressing F4. And also annual revenue needs to be locked in, pressing F4 there as well. And if I enter here, that is the present value of this investment alternative at 1%. So if I copy down the calculations for all these percentages, it's going to calculate the present value at all of those interest rates. And as you can see, between 12% and 13%, the sign of present value changes from positive to negative, meaning that the internal rate of return is between 12% and 13%. So what I'm going to do is to calculate the present worth for alternative B as well. So that's going to be negative $450,000 plus present value of this annual cash flow at 1%. Number of periods is 10, and the annual payment is $80,000, and I have to lock that cell as well. Now if I copy down the calculations, you can see how the present worth for alternative B changes, and right around the same percentage, between 12 and 13%, the present worth becomes negative. So we want to know exactly what is the IRR of them, and we're going to plot them on the graph. And lastly, I'm going to calculate the present worth of cash flow B minus A here. Now, here I have the present worth of B minus A calculated, And we can see that the internal rate of return for that cash flow for the incremental investment is between 10 to 11%. If you graph present worth on the y-axis and the interest rate on the x-axis, you're going to get this graph here. And what we see here is the interest rate on the x-axis, present worth on the y-axis, and when these lines intersect with 0, meaning that present worth is at 0, that is the internal rate of return for those alternatives. Well, as you saw in the Excel demonstration, here's the IRR of B. It's when the present worth of that alternative is equal to 0, so that percentage is IRR of B. Here, this is IRR of A, because the present worth is equal to 0. And here's the IRR of B minus A. Here you can see that at different MARR levels, your decision can change, right? So here, for example, before this IRR of B minus A, here, you would pick alternative B. And that was the case in this problem. MARR was 8%. And you can see at 8%, the green line is above all of the other ones. And that means alternative B is the best one. But if the IRR is somewhere between these 2 points, alternative A is better because it's above alternative B's curve. And if the MARR is greater than IRR of A, that means you're basically better off doing nothing. So here you can see that how MARR changes your best choice. If MARR is in this range, you go with alternative B. If it's in this range, go with alternative A. And if MARR is greater than 12.87, you're better off doing nothing because none of those alternatives will give you that much return.